Hi, and thanks for your time watching this presentation. We are very honored to be here to present our course project, which is credit card customer churn prediction, and below are our team members. Customer churn has remained a big issue for enterprises, and it is the same for banks. Banks have been trying really hard to launch different marketing campaigns to offer different products in order to retain customers. And that's why we feel it's really important to study the credit card customer dataset and use different machine learning algorithm to effectively identify potential living clients. And in this project, we will use the following method to build a machine learning model. We've started with the EDA process. By looking at the histogram of the target variable, we can see that only 16% of the customer have left the bank, which indicates that the original dataset is very imbalanced. We will have to do some oversampling before we train the model. And we use histogram and a line plot to show the distribution for numerical variables, and we use box plot to detect the outliers, if any. For example, if we look at the distribution of credit limit, we can see that it is right skewed and there are a lot of outliers on the high end. And to reduce the effect from the skewness, we take the log of the credit limit. So after the log transformation, we can see that the distribution is more smooth and the outliers are gone. We apply similar methodology to other numerical variables where we have observed a skewed distribution or we have seen a lot of outliers on both high end and low end. We then study the relationship between target variable and the independent variable to see who is more likely to leave the bank. For example, by looking at this graph, we can see that clients with a platinum card type are more likely to leave. Customers who contacted the banks more often in the past 12 months are more likely to leave. Customers with more than 3 bank products are less likely to leave. And then we look at the median of some other numerical measures to study the profiling of the customers between different groups. We can see that overall, the existing customers have higher credit limit, higher total revolving balance, higher total transaction amount, transaction count, and high average credit utilization ratio. And also, by looking at the total percent change for transaction amount and transaction count for the past 12 months. If the percent change is bigger than 1.5, it is more likely to be an existing client. Then we use heat map to display the correlation matrix, and we find that age is highly correlated with months on book, so we have to drop it. We find that transaction count is highly correlated with transaction amount, then we drop transaction count. And after all of this is done, we use dummies for categorical columns. We did the train test split. We use mode to oversample the original dataset to our target of 0.8. Next, my teammate Yexin will discuss logistic regression.
Following up on the EDA process my colleague did, I'm going to talk about logistic regression. The main goal of logistic regression is to establish a baseline for future model fit that we'll be talking in later slides. So we started with logistic regression here. The models, the parameters that we decided to train is a regularization strength of C parameter and either L1 or L2 regularization. And the solver that we're choosing is a linear solver because that's the only solver that supports both L1 and L2 regularization. Using this parameter and the grid search, we find the best model that with the C parameter of being 2.78 and the panel and the regularization using L1 and the solver being the linear one. And the model performance, in terms of accuracy, the model achieved almost 90% of accuracy. And for precision, and looking at the both positive and negative class, it looks okay. But looking at the recall for the positive class, that's pretty low. That's lower than 50%, which means the model failed on identifying some of the positive ones. So the result of some false negative ones, that which is really concerning this case, because this particular model is for identifying the customers that are churning, and that has a business impact. So we want to capture as much churning customer as we can. So I also look at the F1 score, which is a harmonic mean of the recall and precision, and that's still low for the positive one. So then I decided to further investigate into the false negative ones, and looking at a continuous feature for the false negative predictions that the model generated. And I think the one of the metric doesn't really make sense here is the number of months inactive for the last 12 months. And so the false positive ones that has lower number of months inactive in comparing to the true positive ones. So in that case, I think we will need to dig further into this metrics in order to make sure this doesn't compromise the prediction result.
Thank you, Yexing, for logistic regression demonstration. I am going to present the results of our random forest classification model. So we started by setting up a parameter grid for the random forest classifier and testing combinations of hyperparameters such as number of trees, maximum number of features, minimum number of simples to split a node, minimum number of simples at a leaf node, and so on. So we use threefold coarse validation to explore the hyperparameter space. And after feeding the model to the training data, we can see how each configuration performs and find out the most effective configuration. Then we find feature importance, and we can see features such as total transaction amount, total revolving balance, are the two key driving factors in our model's decision-making progress. Next, we see how individual parameter influence the test score. So as the line plots for each parameter showing below, we have a deeper understanding of the model's sensitivities to specific hyperparameters adjustments. And we also see the interactions between pairs of parameters using heat map. So finally, the classification reports. We have an overall accuracy of 94%, which is a strong indicator of the model's ability to identify the charming customers. So by breaking down the report further, we see a precision of 96% for existing customers and 80% for charming customers. So the difference in precision indicates that our model is slightly better than at identifying the negative cases. So looking at the recall, we have 96% for existing customer and 82% for charming customers. So the high recall for both classes states the model's effectiveness in detecting the positive.
Okay, let's go on the SVC model. Why we use the SVC model? Because we want to handle some issues, for example, nonlinearity in data, handling imbalanced data, reboots to overfitting. We use the 10 kinds of configuration in SVC model because different configurations of hyperparameters can significantly impact the performance of the model. Grid search helps find the optimal combination. After running, we got the SVC result. The configuration when the C equals 1, kernel equals liner, achieved the highest occurrence of 91%. It performed the best on average, crossing different cross-validation faults. For the classification report, the model performs well in prediction class 0, Nanching with high precision, recall, and F1 score. However, for class 1 Churn, the model shows low performance, especially in terms of recall and F1 score. This suggests that the model has difficulty correctly identifying class 1. The 5 full negative misclassifications involved instances where the model predicted non-chain while it was chain. The 5 false positive cases reveal the instances where the model incorrectly predict custom chain while it was non-chain. These cases are affected by various customer features, including dependence count, months and booking, total relationship count, and credit utilization. I think further investigation into these instances is essential for understanding the reasons behind these misclassifications if we want to improve the model.
Based on the modeling result, we can say that random forest has the highest accuracy, precision, recall, and F1 score. And because our primary goal is to effectively identify potential living clients, that's why we focus more on the measures for the positive class, and among which we can say that random forest has the highest recall score for positive classes among all of the 3 machine learning models, so we can safely conclude that random forest is the best model so far for this project. And here are some suggestions for future work. Firstly, we look at the top 5 false negative classifications, and we further investigated those instances. We found that we need to furtherly explore the associated features and patterns to enhance the model's sensitivity to customer churn and reduce false negative in predictions. Those are really important for banks in order to retain customers. And there are also a few false positive cases worth looking at. Though it is less important in this project, we would still presume a very low positive rate, as spending too much time on the wrong people is also a waste of resource. And just as my teammates have noted, all 3 algorithms did a better job at identifying negative class rather than positive class, even if we have oversampled the original dataset. More data exploration is needed in EDA step in order to improve the recall score. And that's the end of the presentation. Thanks for your time.